In this video, we're looking at calculating expected probability. What we mean by calculating expected probability is that when we're given a probability of an outcome or a set of outcomes, we can work out how often one outcome would occur after a given number of trials. So for example, if we look at this table in this question here, which we're going to work through, a four-sided spinner gives the following probabilities for each outcome. So if it lands on 1, there's a 0.21 chance. If it lands on 2, there's a 0.62 chance. It lands on 3 is a 0.04 chance. And lands on 4, we don't have a probability yet. So the question asks us, what is the probability that it does land on 4? In order to work this out, we need to know that when we add all of these probabilities up, it's going to equal 1, because all probabilities, if we cover every outcome, the total amount should equal 1. So our first step is to add all of these probabilities up. So I'm just going to show you some column addition just to make it nice and easy. Okay, we get 0.87. So our next step, and we're going to use 1.00 because we're using 2 decimal places here. We're going to do our column subtraction in order to work out what this final probability would be. So we've got 10 take away 7, 9 take away 8, and then 0 take away 0. So our probability of a 4, and we're going to write it like this, because that means probability of 4, is 0.13. And if you like to, you could fill that in your table as well. Okay. Something else we can look at with this expected probability, based on the probabilities given, is bias. And if we know what bias means, it basically means whether, in this case, the spinner is fair. Bias just means if something is fair. Okay, so if something is biased, it means it's not fair. So question B is simply, is the spinner likely to be biased? Now there's a few factors we could take into this. We don't know how they've got these probabilities. If they've done an experiment and this is their decimals that they found from the experiment, okay, it could be that they did a low number of trials. Okay, we don't know exactly how many trials they did to find this probability, or they could have worked out the space each number took up, and that would give a probability as well. But just based off the information here, we need to think, if it was a fair spinner, what would we expect each probability to be? So we can write here, if fair, each outcome would be the same. In this case, 1 divided by 4, because there's 4 outcomes, and the total probability is 1. So it should be 1/4 or 0.25. Okay, if we look here at our table, this is the only one that's really close to 0.25, 0.21. And maybe if they weren't all exactly 0.25, but they were all in 0.2 something or close to that, we could say it was fair. But in this case, we can see 2 is definitely very far away from 0.25, and the others are quite far away as well. So our answer here, we're going to say no, as the probabilities of each outcome vary greatly. So if it did ask you for a reason, that would be a sufficient reason to give. And I'm just going to make that clear because I've given you some extra information there, that this is our answer. We don't need to write the line above down if it was an answer to a question, but in your working it might be useful to write that down. The final thing we're going to look at with this example then is actually working out some expected probability. So if we span 250 times, how many times would we expect a 2? So what we need to think about is have a look at the table. So the probability of 2 is 0.62. Okay, and we're going to do 250 spins. That's our key information for this question. Okay, so 0.62 for one spin, but we're going to do it 250 times. So if you think about that information, one spin gave us this. So if we're doing 250 spins, it's going to be 250 lots of 0.62. And we can just put that into our calculator. And we can see it gives us an answer of 155. Okay, and that's all we have to do in order to work out expected probability. Okay, sometimes it could give you a decimal. Okay, in that case, the question would say to you estimate. Even these questions could say estimate because we don't know these probabilities are exact. And also, another reason that a question is likely to say estimate would be because if you spin it 250 times, you're not necessarily going to get the exact probabilities. These are rough probabilities from one spin. Okay, if we do it 250 times, it doesn't always mean it's going to have the same probability that we would expect it to. Okay, so this is essentially if these probabilities were true and happened every time, how many times would we get a 2? It would be 155 times.